Welcome, everybody. Today, we're going to talk about data modeling with Amazon DynamoDB, and we'll cover this in about 15 minutes. I'm your host, Robert McCauley. I'm a specialist solutions architect here at AWS. Been in this role about 4 years, but I joined the company before this as a relational database developer, and I discovered DynamoDB, and I'm really excited to share what I've learned about DynamoDB with you today. So DynamoDB, what is it? It's a purpose-built cloud serverless database that we created in about 2007 to respond to some problems we had running our own fleet of commercial database engines. We realized that a lot of our access patterns were simpler, single value, key value lookups, and our DBAs were having trouble keeping the fleet of servers up and running. So we really needed something simpler, something that DBAs didn't have to manage, and we invented DynamoDB. We just had a 10-year anniversary for it last year. It's been out there quite a while. We have tons of big customers and small customers using it today for their mission-critical workloads. We've added a lot of enterprise features to DynamoDB, including global tables replication. So you can have multi-region active-active replication, which is really great. I think our favorite thing to tell developers is there's no servers to manage. You don't have to be a DBA just because you're running a database application. It's simply an API in the cloud. You can think of it as a key value store. It does even more than that, but you can think of it as just a way to do reads and writes at any scale. And because we invented it and created it, it's tightly integrated with the rest of the serverless stack and with AWS services. So all the security, for example, in IAM and Cognito and KMS is right there built into DynamoDB. One interesting thing, though, is in that it's a NoSQL database, there aren't joins. There's no joins, so we have to take another approach, and that's really what we're going to talk about today, the idea of modeling. Modeling your database application, your tables, or maybe even a single table, thinking of a schema, and planning for the structure of your data so that you can support the different access patterns that you need to. We'll discuss that. We'll look at one or two case studies, and we'll go to a live demo as well so you can see it all in action. And by the way, we're talking about data modeling, just to be clear. So let's think about what we have before DynamoDB. If you have a SQL database, like MySQL or Postgres, for example, we're all probably familiar with that. Maybe there's a schema with 4 tables, customers, orders, order lines, and products. And you might have an access pattern that says, get me a certain order 234. So you issue that SQL statement, select star from the table where order is 234, and joining everything together with inner joins. And the SQL database engine will magically go and do a bunch of work and give you one result set back, the full order that you asked for. Now with DynamoDB, because we don't have joins, we might still have the same 4 tables. If we don't really model, if we just migrate everything one for one, then we have 4 separate tables just like before. But it may not be a good model because look at the access patterns. First, look in the orders table for that order 234, find it. Notice that there's a customer ID attached to that. Do a second call to the customer table, get that customer information. So you want to return that to the user as well. Maybe now go to the order lines table and find any and all order lines that have the same order number. There was 2 of them. So for each of those, go to the product table and see which product was on that order line. So you end up with 5 or 6 or a lot of access patterns just to prepare a view of a single order. So I think there's a better way to model without having the same number of tables that we used to have in the SQL world. So with DynamoDB and with NoSQL in general, we have this great philosophy called the single table philosophy. And the idea here is by structuring everything to fit in fewer tables, maybe one table, we can prepare the data so it's already collected together. We talk about item collections. Maybe there's an item collection that's got all the order information in the same place so that we can access it with one query instead of multiple requests. But there's many ways to accomplish this. Let's imagine we've been hired as consultants to do this migration between SQL database and our single table DynamoDB. And we're sitting here on the left side of the screen inside our, maybe it's a MySQL database engine, and we want to use our current SQL skills like views and inner joins and things like that to combine the tables into a format that's ready for a single DynamoDB table. How would we combine tables? Well, we already saw one way, the inner join. Let's take a look at that first. So imagine the orders and order lines are collected in a central kind of a transaction table here in the middle. And then on the edges, we have these foreign keys, customer ID and product ID. And the inner join is essentially going to denormalize this for us. So it'll create one very wide, very large, complete data set with a lot of duplicated dimension records on the left and right. But the advantage of having this data set in a DynamoDB table, for example, is you could do a get item for any one order, like this one, and it's complete. It's all there. And doing a single get item is the fastest of all operations. DynamoDB is already pretty fast. Most operations return in 5 or 10 milliseconds, and get item usually returns in like 3 or 4 or 5 milliseconds. So imagine the great latency and the great performance your users will get. You know, they log in on their phone, they pull up an order, and it's there like very, very quickly. So that's the advantage of denormalizing with inner join and denormalizing in a DynamoDB single table. But there's a con to this. The downside of doing this is all the duplicated rows here. And if you ever had to change the customer phone number or the product name, for example, you have more work to do to go and find those and change those. So let's look at a second approach now. And this is the idea of stacking entities together. So instead of joining them, we could ask the source database to do a union. And this would essentially put all the tables vertically on top of each other without mixing them. And we can do this with a view. If we create a view, we can line up the columns that are supposed to line up, like the customer ID and the product IDs we see here, add in a bunch of nulls for placeholders, and eventually we'll get one data set, but it'll be not normalized. It'll be normalized so that we have a single version of customers, a single version of products, and we should have the ability now to do other access patterns like we'll see here. Imagine we get a question, show me all the orders for customer 2. Plus the customer information. Because everything's lined up like this, we can use the key of the data to do a single query, get everything for customer 2, and one query is going to be pretty fast as well, maybe 10 milliseconds to get a set of records like this. We don't have to do multiple steps, multiple hops, go to this table, go to that table, it's all right there, and it performs like lightning fast. And another access pattern we could support with this stacked model is using an index called a GSI. Imagine we have a GSI on the right side here that's going to group by product ID. Find me all the records for product 300, the convertible car. Because they're lined up and we have an index grouping them together in an item collection, we can do a query against the GSI and return those as well very, very fast. So a lot of the data modeling that you'll be thinking about with DynamoDB is what are the item collections that you're going to need to do. A great pattern is to support, to document all the access patterns that you want to support, write them down, and then for each one, think of a strategy, think of how you'd structure the data like this to make it all happen easily. Now you can always do 2 tables or 3 tables if you like, and maybe there's a wizard where the user's going to take 20 seconds between steps, and it's perfectly fine to jump to table 2 and table 3. It doesn't have to be a single table, but if you want really the best performance for single access patterns that come back in 10 milliseconds, think of ways to structure it all in a single table for the best latency. With that, let's take a look at a couple of use cases for migrating relational data into DynamoDB. And here I have a connection to an actual MySQL database. I've got a table out there called contracts, and imagine this is customer contracts. It's quite a simple table. It's really just kind of a key value store. So we have contract ID as the primary key, and then a bunch of text here as the actual contract data. I've gone in and migrated that into DynamoDB in a couple of different ways. Let's see the first way. The simplest way would be just a pure key value access pattern. And there we see in this DynamoDB table, we have a PK, which is our partition key. And we can see that there's a key and a value. So if we just click on any one of these records, we'll get the value, and it could be text, it could be anything you like, binary, JSON, whatever you want to store. So that's pretty simple. Let's try another more robust case. What if we want to have versioning on this table? So we have the ability to create a table with not just a partition key in blue here, but also a secondary key called a sort key. And if you can see here, the blue and the green work together to create an item collection. So here we have the first, first record, but there's actually two versions. There's a V1 and a V2. Here we have another collection with 4 versions, V1, 2, 3, and 4. And this allows us to do versioning. So we can take the original key value store and provide a one-to-many pattern against it. You can imagine somebody would maybe ask DynamoDB for the latest record, open version 4, go work on it, make some changes, come back and try to store version 5 if it doesn't exist yet. Optimistic pattern there. So that's a great way to think about the one-to-many patterns of DynamoDB, or just a simple key value pattern. All right, with that, let's take a look at using the sort key expression. So here we have V2. We can also ask DynamoDB to go against this range of multiple sort key values. Let's get everything that's greater than V2 with a query. So you can see V3 and V4 show up, and everything that's greater than V3 is a single value, so it shows me the record. So when we have this one-to-many pattern here, we can imagine slicing and dicing this sort key up. This could be a date like year, month, day, where we get everything greater than 2023, for example, or any range of dates or sort values. All right, let's close off with a more robust demo. Here we have a table with partition key and a sort key like we learned about. It's got a lot of records in there. Let's scan it and see what we see. Whoa, there's a lot of data there. What we're seeing here is that there's DynamoDB is schemaless. So we'll put this into grid mode. You'll see what I'm talking about. We still have the item collections, partition key and sort key. We have product, city is sometimes null. We have this big payload that's colored in a different color, and a bunch of other attributes. And we can now do the same kind of access patterns that we saw sort key ranges, but we also can use the power of indexes. What if we wanted to group by city? Find me all the records for all customers for the city of New York. Look, as I hover over this index here called GSI1, I can see that there's another data structure available to me as a developer called a GSI, where I could provide a certain city and get me all the records that match that. And you can have the multiple indexes as many as you like. You can tune them. This one here is really sparse. It only has a few attributes that I need. It's grouping by product and sorting by status. All right, with that, let us go back and just wrap up what we learned today. So DynamoDB is a serverless cloud key value database that can support most of your relational access patterns. It doesn't have joins, but we can build collections of data in a single table. To model your access patterns, we need to understand what the access patterns are, and then think of ways to group data so that they'll be available with quick access patterns like queries. And we can think of single table design where it helps when we want to get the very best latency from DynamoDB. Hope you enjoyed the short talk today. Thanks for your attention. I'm Rob McCauley. There's my email and my Twitter handle. Let's get in touch. Show me what you're building. Until next time, thank you and take care.